Okay, so we are going to go through this pretty quickly. We just did in video 5D, we went up the incline with friction. Remember, you can hit pause, you can rewind me, so I have an excuse for going fast. Okay, so once again, let's just go through this. We had a force up the incline. So there's my incline, and my height, that's not to scale, I should be to scale, but my distance along the incline was 1.28 meters. My force in that direction was 12.5 newtons. My height was 0.525 meters, and let's see. Okay, so that's where we're going to go. So my force was 12.5 newtons along the incline. Then my distance was 1.28. Then next I want to have my mass, which I measured to be 1.90 kilograms. And my velocity I'm going to calculate very quickly shortly. My g was negative 9.81 meters per second squared, and my height, I'm just going to ignore that negative there, my height was 0.525 meters. Okay, so then xt, vi, vf, a, don't care about that. That's 0 meters per second. My time that I measured in that experiment was 1.2 seconds, and my mass was 1.90. I'm sorry, my distance was 1.28 meters. And so then my result that I had from previous, you can look back on that. Here's my derivation of that. You can hit pause and look at it. I'm going to come up with my V final was going to be 2 times 1.28 meters divided by my time, which was 1.2 seconds. So I'm going to say that my final velocity as calculated (2.1 meters per second). Put it down there too. Okay, so now going through this really quickly, I've got my work equals force times distance. So my work is going to be 12.5 newtons times 1.28 meters, and so my work is going to be 12.5 times 1.28. It's going to be 16 joules. 16 joules. And then we're going to say my GPE was going to be mgh. So my GPE is going to be 1.90 kilograms. G 9.81 meters per second squared, and height 0.525 meters. So I plugged this in. And I get 9.8 joules. And then my kinetic energy is 1/2 mv squared. So my kinetic energy is 1/2 times 1.90 kilograms times my velocity was 2.1 meters per second, and that's got to be squared. And I get 4.2 joules. Okay. Well, if we think about this now, in the previous, when I had wheels, the work that I did was 3.5 joules. The kinetic energy that it gained was 3.2 joules. And then the kinetic energy when I let it slide back down to the bottom of the ramp was 3.3 joules. And we said that if everything worked out perfectly, all three of those numbers would be the same. These numbers are clearly not the same. So I did 16 joules of work, but then it only ended up with 9.8 joules of energy, of gravitational potential energy. Then I let it slide down the ramp, and when I slid down the ramp, I only ended up with 4.2 joules of kinetic energy down at the bottom. So clearly some energy is missing. Okay? Well, I'm going to say 16 joules minus 9.8 joules is going to be 6.2 joules. And that's going to be lost to friction on the way up. Now I'm going to say 9.8 joules minus 4.2 joules. That I can do that in my head. That's 5.6 joules lost to friction on the way down. Okay, so I lost 6.2 joules to friction on the way up. So 16, lost 6.2, ended up with 9.8. Sliding down, I lost another 5.6 to get me to 4.2. Now, here's where I'm going to go kind of fast. I'm going to say that the average energy lost was, I'm going to say, that's 6, so I'm going to say 5.9 joules lost over 1.28 meters. So I'm going to say that the work equals force times distance. There was 5.9 joules, force 1.28 meters. So my force friction, I'm saying that my force friction 5.9 divided by 1.28 is going to be 4.6 newtons. Okay. I'm going to be running out of time here, and I don't want to run out of time, so we're going to continue this in the next video.